All right, I want to talk about, excuse me, I want to talk about using transformations to graph rational functions. I'm eventually going to talk about a more complicated graphing of rational functions process, but here's my idea. Suppose I've got y equals x minus 5 over x plus 2, and I want to graph it. So what I'm going to do is I'm going to start with a base function of f of x equals 1 over x. So if I have f of x equals 1 over x, that looks like this. It's got a horizontal asymptote at 0. It's got a vertical asymptote at 0. It's in the first quadrant and the third quadrant. So the trick is I'm going to use some algebra to rewrite my y here so that it is a shifting and scaling of f of x. And then I'm going to use what I know about how graph transformations work to graph it. So the first trick is I'm going to go bust out the polynomial long division to calculate x minus 5 divided by x plus 2. So x plus 2 goes into x minus 5 once and leaves a remainder of negative 7. So this is 1 minus 7 over x plus 2, which I can think of as negative 7 over x plus 2 plus 1. So now here is, so this is negative 7 times 1 over x plus 2 plus 1. But that's negative 7 times this function f evaluated at x plus 2 plus 1. So what is this? This is a shift to left. So negative 7 means you reflect through the x-axis, then you scale by a factor of 7, and then you shift up 1. And so what I do is, so let me write negative 7 times f of x plus 2 plus 1, and that red graph is what my function should look like. And I'm just gonna edit this like that so I can see it, and then I'm gonna type y equals x minus 5. I gotta do it like this: x minus 5 over x plus 2. And edit the color here. We'll make this red. And so you can see that it's doing what I wanted it to do. But so you can use this in order to graph rational functions, simple rational functions. This trick is not going to really work if I give you something more complicated. If I give you something like g of x equals x minus 7 over x squared plus 3x plus minus 4. So in order to graph something like this, I'm going to have to do a more complicated multi-step process. And so the process I usually do is, first off, I identify intercepts. Intercepts has a t in it, x and y. I identify vertical and horizontal asymptotes. I use arrow notation to identify directions at asymptotes. I'm going to use sign analysis to find when the graph is positive, when it's negative, and then I'm going to sketch the graph. So I'm going to delete all of this, and I'm going to write y equals fraction x over 2. So I can turn this off so then I can reveal at the end that I managed to actually sketch something that sort of looks like the right graph. All right, so the first step of the process here is going to be my function, so I think I called it f of x. I can factor the denominator, so I get x minus 7 over x plus 4 times x minus 1. So in order to find the y-intercept, you're going to set x equals 0, and you're going to find y. So f of 0, if I look at the original expression, is 0 minus 7 over 0 squared plus 0 minus 4 is 7/4. So my y-intercept is the point 0, 7/4. So there is my y-intercept. So to find x-intercepts, I'm going to set y equals 0, and I'm going to find x. So if 0 is x minus 7 over x plus 4 times x minus 1, then that's the same thing as saying 0 is x minus 7, because you can, if a fraction equals 0, its numerator equals 0. And its denominator doesn't. So -4 and 1 are the bad points. So the domain is x doesn't equal -4 and x doesn't equal 1. So x equals 7 here is in the domain of the function. So that means that if I give you the point 7, 0, that's on the function, and it is going to be an intercept. I'm going to label this, and there's that point. I'm going to zoom out a little bit. All right, so let's keep going. Horizontal asymptotes. So remember, for horizontal asymptotes, you look at the leading term of the top over the leading term of the bottom. And so that equals x over x squared, which is 1 over x. And so remember, when you have x's left in the denominator after we do this process, because the degree of the denominator is greater than the degree of the numerator, that tells me that y equals 0 is my horizontal asymptote. So I'm going to draw a dashed line at y equals 0, and I'm going to actually change all these colors to red because I want to. All right. And so then in order to find vertical asymptotes, you're going to solve the equation x plus 4 times x minus 1 equals 0, because you're going to use the simplified denominator in order to find the zeros. And so you get x is negative 4 and positive 1. And so I can graph x equals negative 4 and x equals 1. And again, I'm going to change their style. And so that's that. So now what I'm going to do is my sign analysis. So in order to figure out the direction that the graph goes at the asymptotes, and in order to figure out when the graph is above or below the x-axis, I'm going to do the following process. So the idea is the function can only change sign at x-intercepts or vertical asymptotes. And so I'm going to draw a number line. I wish that was a straight line. Boop. This is probably overkill, but I don't care. At, let's see, so negative 4, 1, and 7. So here's what I'm going to do. My expression equaled x minus 7 and x minus 4 and x plus 1 all in a big expression. So then you've got x minus 7 over x minus 4 times x plus 1. So I'm going to pick test values. So negative 5 is less than negative 4. 0 is between negative 4 and 1. 3 is between 1 and 7. And 10 is larger than 7. And what I'm going to do is for each factor here, I'm going to figure out if it's positive or negative at this number. So if x were negative 5, x minus 7 is negative 12, which is negative. X minus 4 is negative 9, and x plus 1 is negative 4. So all three factors are negative when x is negative 5. So then this is a negative number divided by the product of two negative numbers, which is a negative number. Now if you try 0, x minus 7 is negative, x minus 4 is negative, but x plus 1 is positive. So then when you calculate the expression, you have a negative number divided by a negative number times a positive number, and those two negatives cancel out, and the whole thing is going to be positive, which I knew anyway because it's got to go through the point 0, 7 fourths. It's got to go through that intercept. All right. Now, between 1 and 7, you get 3. So x at 3, how do I get 3? Oh, there should be negative 1. Oops, I screwed that up. That's how I get you. Oh, plus 4, negative 1. So that's fine. That's right. And this was right. Negative, positive, negative, negative, positive, negative. That's embarrassing. I'm sorry. I've come too far. All right. All right. So I had the sign right, but I screwed up the sign analysis because I got those factors wrong. All right. So let's just keep going. All right. All right. So if x is 3, then x minus 7 is negative 4. X plus 4 is positive 7. And x minus 1 is positive 2. So then you're going to have a negative number over two positive numbers. So the whole thing's going to be negative. And then if you get 10, then you've got positive, positive, positive. So everything is positive. And the whole thing is positive. And so the graph is going to be below the x-axis, above the x-axis, below the x-axis, and above the x-axis. So what's that going to look like? X equals 1, 7, 0, 0, comma, 1, 7 fourths. And so, okay, so it starts negative. So you need to start close to the horizontal asymptote, which is y equals 0, and then it's negative. So it cannot cross the vertical asymptote, so it's got to go down like this. And then between -4 and -1, it's positive, so I have to start up here, because I can't be below the x-axis. I have to go through the y-intercept. Then I have to go up here to positive infinity, because I can't cross this vertical asymptote. So then between 1 and 7, I'm negative, so I start down here, and I increase until I hit the x-intercept, and then after the x-intercept, I'm positive, but then I level back off, and I get a graph that looks something like this. So now I'm going to push the button, and that is more or less what it looks like. You can't exactly see the little bump here at the end because the scale of it is not as massive as I made it look. But just to show you what's happening, let's say this is 0, and let's say this is 0.5. So if you zoom in a little bit there at 7, 0, you can see the little bump I'm talking about. But it's very, very slight. So these graph sketches are not perfect, but they give you a rough idea of what the shape is.